Welcome to EDU World Space.
Let's try to figure out the number of atoms in different amounts of substances. All right, so we're not looking for number of molecules or moles, but we're looking for the number of atoms. So let's take a look at something that has a half a mole of water. So we have to get this into atoms. We use Avogadro's number in order to do that. So we have our half a mole. We know that every mole of a substance has 6.02 times 10 to the 23rd. Now, water is a molecule. So moles divided by moles will cancel out. That'll give us molecules. We don't want to know how many molecules there are. We want to know how many atoms there are. So how many atoms are there in water where there's two H's and an O? So there's 3 atoms in one molecule of water. And so now we can have our molecules cancel out. And so we can now just put this into our calculator, and we wind up with 9.0. I only have 2 significant figures, times 10 to the 23rd atoms. So that's how many atoms there are in a half a mole of water. Now, what about 23 grams of sodium? Well, we can take our 23 grams. We can use molar mass to convert to moles. So when you look up sodium on the periodic table, 22.99 grams. That'll get us to moles, but we want to go to atoms. Well, Na, there's only one atom there, right? So we have one atom. Let me take that back. We have 1 mole of Na is 6.02 times 10 to the 23rd atoms. Now, why is this one atoms and not molecules like we had up at the top? Well, here it's just Na. It's only an atom of sodium. For water, we had molecules that we had to convert to atoms. Here we already have atoms. So I can take my grams and cancel out. I can take my moles and cancel out. I would be left with atoms. And so again, we only have 2 significant figures that we're allowed to have our answer to because of the 23 in the 23 grams. And so that is going to give us 6.0 times 10 to the 23rd atoms. So far the water is in the lead, but let's take a look at 6.0 times 10 to the 23rd molecules of N2. Oh, well, look at that, N2. There's 2 atoms of nitrogen in N2, so we're going to have to take our 6 times 10 to the 23rd molecules of N2, and we're going to have to say this time, we have to convert it to atoms, there's 2 atoms of N in every 1 molecule of N2. So we're actually going to have to multiply that value by 2. And so the 2 significant figures we're going to get 1.2 times 10 to the 24th atoms. So it turns out between the 3 of them that the nitrogen winds up having the most. Then the water has the next, and the sodium has the least. So if we want to go in increasing means smallest to largest, we're going to have to go sodium, followed by water, followed by nitrogen.